In this section, we'll look at something called the law of cosines. Let's start with the warm-up. Find the measure of the missing side of the triangle. Round your answer to the nearest tenth of a centimeter. So first thing you check is it a right triangle? Because then you can use right triangle trig SOHCAHTOA. So if you take 180 minus 33 minus 42, you want to see if that angle is 90. So there's the first step. Check this angle. 180 minus 33 minus 42. And that ends up being 105 degrees. So this is not a right triangle. You can't use right triangle trig. So then you have to check, can we use law of sines? Law of sines, look for a complete ratio. Do we have a side and its opposite angle? And we do. So we're going to use law of sines to solve. Sine of 33 over the opposite side, 12, equals, and let's solve for x here. So to set up the proportion, we know that equals sine of x, or sine of 42, the angle, over side x. So there's law of sines. We'll cross multiply and solve. We have 12 sine of 42 equals x sine of 33. To get x by itself, we'll divide by sine of 33. Again, make sure you're in degree mode. And you might want to put this in parentheses. So type that in, and you'll get your answer. Side x is about 14.7 centimeters. Today we're going to look at how to solve a case like this, where if you notice again, it's not a right triangle. This is 100 degrees right here. We don't have a complete ratio. What I mean by that is, okay, we have the 100, but we don't know the side. We know side 5, but we don't know its opposite angle. And we know angle A, but we don't know, or we don't know angle A, even though we know its opposite side. So law of sines won't work because we don't have a complete ratio to use to solve. Any ratio that we would try to set up, you would have two variables and you wouldn't be able to find, or wouldn't be able to solve for one of them. So why won't law of sines work? You don't have a complete ratio. There's not enough information to use. Can you draw at least two different situations in which law of sines would not work? In other words, you wouldn't have enough information. And one example is like the one above. So the one above is when you have not a complete ratio. So perhaps you have this side is, how about 2, but we don't have this opposite angle. This side is 3, but we don't have its opposite angle. And maybe this angle is, I don't know, 47 degrees. So here we don't have a complete ratio. Another time it won't work is if you have 3 sides. So let's say that this is 6, and this is 7, and this is 8. We don't have any angles, so we can't use law of sines. We wouldn't have a complete ratio. So side, 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 if you have that, it's not going to work. And if you have side, angle, side, law of sines doesn't work. All right, I should have drawn that down here. All right, when law of sines doesn't work, we use something called law of cosines. And I'm going to give you the formulas, and then we're going to watch a video on how they got the formulas. So let's start by drawing a triangle. I'm labeling it. Let's use red. Okay, so let's say that this is my triangle right here. And let's call this ABC. And angle A is across from side A. Angle B is across from side B. Angle C is across from side C. Here is law of sines. The first one is A squared equals B squared plus C squared minus 2BC cosine of A. All right, that's if you're solving for side A or angle A. How about if you want to solve for B, side B or angle B? We switch the order, so B and A I'm going to switch in this equation. So B squared will be A squared plus C squared minus 2AC cosine of B. And what if you want to solve for side or angle C? We'll switch C and B here. C squared equals A squared plus B squared minus 2AB cosine of C. Now it looks kind of complicated, but it's actually not. If you can remember, the side comes first, and whatever side you start with, it ends with that angle, and the other two sides come in between. It's not really that difficult. So let's watch a video on how they came up with these formulas.
The law of cosines.
Good morning, staff. There will be an all stand-up staff meeting at 8 o'clock in room C350. A stand-up staff meeting in C350 at 8 o'clock.
When you have a triangle with sides of length A, B, and C, and we've labeled also here the angle that's opposite side of length C as angle C, then it's always true that C squared equals A squared plus B squared minus 2AB cosine C. The reason this is useful is it gives you a formula for finding the cosine of an angle in the triangle only using the lengths of the sides of that triangle. So let's derive that here. So we're going to derive the law of cosines. First, we're going to draw an altitude z in this triangle to side B. And now we're going to divide the side B into lengths x and y, going to that altitude. And now we're going to use the Pythagorean theorem to say that c squared equals y squared plus z squared. Now, y is also equal to b minus x, since x plus y equals b. We can square both sides of that to get y squared equals b minus x squared. And again, using the Pythagorean theorem, we can show that z squared equals a squared minus x squared. So the reason that we did these last two steps is we can now substitute these expressions for y squared and z squared into our original equation. So we can now write c squared equals b minus x squared plus a squared minus x squared. And now we can expand the b minus x squared term. So we have b squared plus x squared minus 2bx plus a squared minus x squared. And notice that the x squared terms cancel, leaving us with c squared equals a squared plus b squared minus 2bx. Okay, now we want to get rid of this x term, since the law of cosines only involves the lengths of the sides of the triangle, a, b, and c, and the angle c. So we want to get rid of this x. So we'll note that the cosine of c is equal to x over a. And so x is equal to a cosine c. And we can substitute this back in to get the law of cosines. C squared equals a squared plus b squared minus 2ab cosine c.
I should stop that. Okay, let's close that. Okay, so there's just a brief intro on how they got the formula. So the rest of the podcast, we're just going to take a look at examples of that. Okay, so again, use law of cosines for oblique or non-right triangles when you have the two cases, side, 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 or side, angle, side. We did that on the front. But again, I'll draw a picture of that so you can see what that looks like. So side, side, side would be if you had three sides, A, B, and C, but nothing else. And side, angle, side would be if you had some side here, some angle, and another side, but nothing else. So in these two cases, you have to use law of cosines because there's not enough information for law of sines. Let's do a few examples. The pitcher's mound on a women's softball field is 43 feet from home plate, and the distance between the bases is 60 feet as shown. The pitcher's mound is not halfway between home plate and second base. How far is the pitcher's mound from first base? So let's just label everything here. It's kind of labeled for you, but I'm going to relabel it. I'm going to call this angle A right here. I'll call this angle B, and this angle C. And we have two sides. Side C right here is 43, and side B is 60. So our goal here is to find the distance between home plate and first, and we'll call that side A. And so the formula we're going to use is a squared equals b squared plus c squared minus 2bc cosine of a. Let's plug everything in. We don't know a, but we know everything else. So b is 60 squared plus 43 squared minus 2 times 60 times 43 times the cosine of A, and angle A is 45 degrees. So this is what I call a plug and chug. You can type this directly in your calculator just like it is right here. And we'll get A squared equals some number, so let's try typing that in. So again, it's 60 squared plus 43 squared minus 2 times 60 times 43 times the cosine of 45. Hit enter. All right, so there it is, 1800.33. And then we're going to take the square root of that to get A by itself. In your calculator, let's do the square root, so control x squared. And then instead of trying to just type in the decimal, it's better to use the answer key, so control negative, and that'll be more accurate than trying to type in the decimal. And so there's our answer. It's about 42.43 feet. Let's just round. A is about 42.4 feet. Okay, so the distance between the pitcher's mound and first base, about 42.4 feet. So today we're just looking at using law of cosines to solve for side. Tomorrow we'll look at how you use this to solve for an angle. Again, you plug in, you calculate, you take the square root. It's not too bad. Figure out the distance between the two trees in this for the survey. Again, I'm going to label our coordinates here. We'll call this angle A, B, C. And again, we're looking for side A here. So A squared equals B squared, which is 100 squared, plus 75 squared minus 2 times 100 minus 75 times cosine of 32. Again, you type that all in your calculator, this thing. So A squared will be 2904.28, and then take the square root of that. And remember, in your calculator, you should do the square root of your last answer. And A is about 53.9 meters. So there's the distance between the two trees. Okay, last example. Find the length of the tunnel. Again, we're solving for side A here, so we have A squared equals B squared, so 300 squared, plus 200 squared minus 2 times 300 times 200
One more quick
cosine
reminder,
of
we're going
80.
to have a really super quick, like 3 or 4 minute staff meeting up at
Type this in.
Please hit us now if you can. Thank you very much.
A squared equals 109, so 109,162. Take the square root of that, and A is about 330.4 feet. So in summary here for law of cosines, use it when you can't use right triangle, trig, Pythagorean theorem, or law of sines. So in other words, when you have side, 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 or side, angle, side. And the formulas are A squared equals B squared plus C squared minus 2BC cosine of A. Or switch the order for B, switch A and B, so we'll have A squared plus C squared minus 2AC cosine of B. Or for C, it's C squared equals A squared plus B squared minus 2AB cosine of C. So you're going to practice just solving for sides today, and we'll take a look at using law of cosines to solve for angles tomorrow.